Hello everyone. Today we are going to start a very new chapter which is aldehydes, ketones and carboxylic acids. Myself Suman Singh. So as in the previous chapter we have learned about the two classes of organic compound which was alcohols and ethers, right? And with the functional group containing carbon oxygen single bond, right? Now there are other class of organic compounds also with a functional group containing carbon oxygen double bond, okay? And this contains an important functional group which is known as carbonyl group, which is this carbonyl group, okay? Now the majority of biological importance compounds containing carbonyl group, and these are widely spread in the plants animal kingdoms and it plays a very important roles in many biological processes of life. Now they are, if you will see the uses of this compound, so they are used in many food products, pharmaceutical agents, and the synthetic materials like perfumes, plastics, fibers, paints, resins, and etc., which is needed in our everyday life, right? So first class is, as you can see, carbonyl compound. When we talk about the carbonyl compound, as you can see, the first class is what you can see, ketone, right? When you will see the ketone, the general formula is this, as you can see here. The general formula of ketone is this, and whereas another class is what, aldehyde, okay, whose general formula is this, as you can see here. Now again, when we talk about the carboxylic acid, you can see the general formula of carboxylic acid here. And when we talk about the acid, acidic chloride, as you can see, the general formula of acidic chloride is here, amide is here, as you can see, and ethers are there, right? So when we talk about the ketones, so what we can say, in ketones, two alkyl group bounded to a carbonyl group, right? In ketones, what we can say, the two carbonyl group is bounded to a carbonyl group, right? Now again, when we talk about the aldehyde, what we can say, one alkyl group and the one hydrogen bonded to the carbonyl group, right? So as you can see, you can understand from here, as you can see, in, if you are talking about the ketone, this side and this side, in both the side they are attached with the carbonyl group, right? But here in case of aldehyde, you can see one side is carbonyl group but the other side is hydrogen, right? Now when we talk about the structure, you can see the structure of this carbonyl compound is like this, okay? With the bond angle is this 120, this is also 120, and this is also 120. Now again, when we talk about the type of hybridization, it will be a sp2 hybridization, as you can see, it has been written here now. And when we talk about the, in ketones, when you will see the carbon and oxygen bond in ketone is sp and sp, right? sp, it is formed by the sp overlapping, okay? And bond length, when we talk about the bond length, as you can see, 1.23 Armstrong, and the energy, which is 745 kilojoule per mole, okay? Now again, when we talk about the alkenes, as you can see, alkenes, the bond length is much more bigger, right? As you can see, it is when you talk about the carbon and oxygen bond, here the bond length, you can see, it is 1.23 Armstrong. But when we talk about the alkenes, in alkenes the bond length is more, right? 1.34 Armstrong. But when we talk about the energy, so energy is less, as you can see, 611 kilojoule per mole, but in this case the energy is 745 kilojoule per mole, right? So this is a basic difference between them. Now again, when we talk about the how it will be found in the nature, or we can say how we can represent it. So though this carbonyl compound can be represented like this also, but most of the time you will see like this, right? Now again, when we talk about the dipole moment, so as you can see, when we talk about a dipole moment, as you can see, this group is what, it is electron donating group, right? So it will donate electron to this side, so dipole moment will be this side. When we talk about this oxygen, it will be this side. So overall, what we can say, the dipole moment is this side, right? So as you can see, the dipole moment of this acetaldehyde is what, 2.7 dBi, right? And for when you will see the general of this, here this CS3 is also denoting an electron, this CS3 is also denoting an electron. And when we see the dipole moment, net dipole moment is this side, right? And this is called what? Acetone. And as you can see, the dipole moment is 2.9 dBi, right? So this was about this. This was the basic introduction about the aldehydes and ketones. Okay. Now we will talk about the nomenclature of aldehydes and ketones. So when we talk about the nomenclature of aldehyde and ketones, this will be of two types, means the common system and the IUPAC system. So I will try to explain you what is the rule for writing the naming this aldehyde according to the common system and as well as according to the IUPAC system. So according to the common system, aldehydes are named according to the name of the corresponding carboxylic acid which they form on oxidation, by which they form on oxidation. Okay. And the suffix we are using here IC acid. Okay. The suffix which we are using here is IC acid. Okay. So IC acid of the name of the acid is replaced by aldehyde. Okay. Suppose we will take the example. Suppose we have acetic acid which is CH3 and COOH. Okay. So this one, what we will do, this is what acetic acid, right? So in the name of acetic acid, what we will do, in the place of acetic acid we will use here ACETAL. Okay. DEH, sorry, ALDE DEHY DE. Okay. Acetaldehyde. So as you can see, in acetic acid, in the place of IC acid we have used aldehyde, right? So as you can see, the name what we can write, for acetic acid we can write acetaldehyde, right? Now, so when you will see the IUPAC system of this, this was about the common system. Again, if you talk about in IUPAC system, the aldehydes are known as their alkyls, ALKANALS. Okay, alkanals. And the name of the aldehyde is derived by replacing E of the name of the corresponding alkene by Al. Okay. So for example, as you can see, there are lots of examples there. For you can take the example of methanol. You can take the example of methanol, which is HCHO. So what is the name of this compound? The name is what? Methanol, right? METHANAL. Okay. Now next is when we see the rule. So the rule is the longest chain containing CHO group is considered as a parent chain, and the name is derived by replacing the terminal E of the name of the corresponding alkene by Al. Okay. Now next case, what we can say, in case of the substituted aldehyde, the parent chain is named in such a way that the aldehydic group, that CHO, gets the lowest number, that is 1. And after that, the third one, what we can say, the position of the other substituents are indicated by numbers. Okay. And at last, what we can say, when the aldehydic group is attached to the ring, the suffix carbaldehyde is added after the full name of the cycloalkenes. Okay. And the numbering of the ring carbon atom starts from the carbon atom attached to the aldehydic group. Okay. So this was about the naming of aldehyde. Okay. Aldehyde and ketone. Okay. So for ketone also, what we can say, this was about the aldehyde. Now for ketone, what we can say, that the same thing is there. The longest chain carrying the carbonyl group is considered as the parent chain, and the name is derived by replacing the terminal E of the name of the corresponding alkene by suffix ONE. Okay. And next thing what we can say, that the position of the carbonyl group and the substituents is indicated by the number. So there are some of the example, as you can see it is given. So when we take the example of this, as you can see, the numbering should be from this side 1, 2, 3 and 4, right? So what will be the name of this? How many carbon? 1, 2, 3 and 4 carbon, right? 4 carbon means butane, okay? butane, butane. But in the second position you will see ketone is there, right? So what we will write? We will write butane 1, right? Not butane 2 1, right? Because you can see here, if there is a, they are not, there is a, in this in this naming, or you can in this compound, they are not talking about the positional isomer, right? So what we will do, we will not write butane 2 1, we will write only butane 1, okay? Now if you will see the type of bonding, so between this carbon and this carbon, there is a sigma bond, which is sp3 and sp2 sigma bond, right? Between this and this carbon, there is again sp2 and sp3, and between this carbon and this carbon, again sp3 and sp3 and sp3, okay? And between this carbon and hydrogen, between this carbon and hydrogen, there is as you can see, sp3 and s. After that, between this carbon and oxygen, there is sigma sp2 and p, right? So these are some type of the bond present in, type of sigma bond present in this compound, okay? Now next example we will see the example of this. So how we will number this? We will number like this: 1 2 3 4 and 5, okay? So 5 carbon means butane, right? 5 carbon means pentane, right? So as you can see, in the second position methyl group is here, and in the fourth position methyl group is here, right? So what we will write? 2 2 2 4 in the second position, and fourth position methyl is there, right? So how we will name this? We will name like this: 2 4. How many methyl? 2 methyl means dimethyl, right? How many carbon? 1 2 3 4 5 carbon means pentane, okay? And on which position ketone is there? On the third position, so we will write 3ONE1, right? So I hope you have understood this. Now next, if we are numbering this one, so how we can number this? We can number like this: 1 2 and 3, right? So how we will write? In the first position phenyl group is here, so what we will write? 1 phenyl. After that, how many carbon? 1 2 3. 3 carbon means propane, okay? On which position ketone is there? On first position, so we will write 1ONE, right? Next, for this, how we can number this? As you can see, numbering should be 1 2 3, right? So how we can write? In the third position methyl group is here, so what we will write? 3 methyl. As you can see, 3 methyl, okay? And this is what? This is cyclopentane, right? 1 2 3 4 5 carbon means cyclopentane. As you can see, cyclopentane, okay? And in the first position 1 is there, so it has been written cyclopentane 1, right? Like this. Now next one, this one, if you want to number this, how we can name this? We will give the number 1 2 3 4 5 6 like this: 1 2 3 4 5 6, okay? So it is what this is. How we can name? We can name like this: cyclohexane, like 6 rings, 6 carbon means hexane, right? But and this is a cyclic compound, so it will be written as cyclohexane. In the second position, double bond is there, so we will write in here 2 in, okay? In the first position ketone is there, so 1ONE, as you can see, 1ONE, right? So in this way we can number this. Now one example we will see for aldehyde also. So this is an aldehyde group. How we will number? Because we will give the number to this, right? Lowest number to this aldehyde, so we will write like this: 1 2 3 and 4. So in the third position phenyl is there, so how we will write? 3 phenyl. How many carbon? 4 carbon means butane. And on which position aldehyde is there? In the first position, so Al, right? Now again this one, yes, this one. So if this type of wage and dash is given, right? If you will see that wages and dash are given, so at that time we have to give here their stereochemistry, right? Stereo chemistry we have to write that one, okay? So in this way, in this question you see, this is what they are trans, because one hydrogen is above the plane and one hydrogen is below the plane. Means what? They are trans, right? So how we can write trans? After that, in how we will number this, we will give the lowest number to this. So 1 2 3 4 5 and 6. So in the second position you see methoxy is there, right? Methoxy is there, and this is what? Cyclic compound, right? So cyclohexane, methoxy, and the first position there is aldehyde, right? So how we will name this? And because one hydrogen is above the plane and another hydrogen is below the plane, so this is what we can write there. We can write that this is a trans, right? In the second position there is methoxy, so 2-methoxy, cyclohexane carbaldehyde. Okay, as you can see here, name is written. Okay, so I hope you have understood the naming, right? So now we will see the next, which is preparation of aldehyde and ketone. Okay, so when we talk about the preparation of aldehyde and ketone, the first is from alcohol. Okay, from alcohol. So as you can see, when we talk about the oxidizing agent, some of the oxidizing agent I have written here. Suppose the oxidizing agent is Collins reagent. So Collins reagent, in which it is CrO3 plus pyridine and 0.3, approximately 0.3 of acetyl ACOH. Okay, as you can see, at that time when we will use this as a reagent, at that time 1 degree alcohol will change into aldehyde. Okay, and 2 degree alcohol will change into ketone. Okay, now again, if you are taking here second one, which is PCC and PDC, we have also discussed about PCC and PDC in your alcohol, right, alcohol chapter. So if you are using here PCC or PDC, at that time if you are using PCC, so PCC is this is the structure of PCC, as you can see, right? So PCC, it will not change double bond into double, it will not change double bond or double bond, it will not affect double bond, it neither it will affect the triple bond, right? But it will, what it will do, PCC, what it will do, it will convert 1 degree alcohol into aldehyde and 2 degree alcohol into ketone. Okay, in the same thing if we are using PDC, so the same thing will happen. If we are using here PDC, this is the formula of PDC. So PDC, if we are using at that time also, it will, PDC will also change 1 degree alcohol into aldehyde and 2 degree alcohol into ketone. Okay, now next, if you are taking the oxidizing agent as MnO2, so MnO2 only oxidizes allylic and benzylic OH. Okay, MnO2, when we talk about the MnO2 will oxidize only allylic and benzylic OH. Okay, and when we talk about, when we take the example of this OAC4 times Pb, so when we talk about this will also do the same thing. It will convert 1 degree alcohol into aldehyde and 2 degree alcohol into ketone. Okay, so we will see some of the example. As you can see, suppose this is the example here, this is a double bond here, right? So what I have told you, if we are taking here MnO4, so what I have told you, MnO4 only oxidizes allylic, right? So which one is allylic here? This one is allylic OH, right? So MnO2, when we are using MnO2, at that time this is allylic, right? OH, this OH is allylic, so it will change this, but it will not change this. When you are taking MnO2, it will not change this, it will change only this. Okay, so as you can see, when it has changed this, we have got what here, in this place of OH, in this place of OH, ketone has come, right? Now again, when we are talking about the PDC, so what I have told you, PDC or PCC, they will not affect double bond, right? As you can see here, double bond or triple bond. So as you can see, double bond is same as it is, right? Now in place of, what it has done, in place of OH, now ketone has come, right? So I hope you are understanding this. This is very easy. Now again, if you are taking here H2Cr2O4 or H positive, or again if you are taking PbOAC 4 times, so at that time what will happen, you see here, if you are taking H2Cr2O4 H positive, so at that time in place of OH you will see ketone has come, in place of OH ketone has come, right? And as well as it is changing the double bond also. But what I have told you, that MnO2 or any other thing, when we are taking the MnO2 or Collins reagent or PDC, PCC or MnO2, at that time they were not changing the double bond, right? But here you will see that when we are taking H2Cr2O7, and it is changing double bond also. As you can see, double bond has changed like this, right? C double OH, C double OH, and here OH has changed into ketone, as you can see, and here also OH has changed into ketone, right? Now again, if you are taking here PbOAC 4 times, at that time you can see the OH is changing into what? Ketone, right? As you can see here, but it is not changing the double bond. So I hope you have understood this, that whatever the oxidizing agent I have seen here, you are seeing here the Collins reagent or PDC, PCC, MnO2 or OaCO4, they will not change double bond into triple, they will not affect the double bond or triple bond. But what if it, most of the time what they will do, if you are using a Collins reagent, they will change 1 degree aldehyde, 1 degree alcohol into aldehyde, 2 degree alcohol into ketone. Again, when we talking about the PDC or PCC, they will also do 1 degree alcohol into aldehyde and 2 degree into ketone. After that, when we are talking the MnO2 only oxidizes the allylic and benzylic OH. And after that, when we are taking OAC 4 time Pb, at that time this will also change 1 degree into aldehyde and 2 degree into ketone, right? So I hope you have got some idea about the preparation of um, alcohol, preparation of aldehyde and ketone from alcohol. Okay, so we will see one example also. So how we can see, how we can tell that from by oxidation from alcohol, when we talk about from alcohol, the first one is by oxidation, okay, and another one will be by catalytic dehydrogenation of alcohol. Okay, these are the two processes from which we can prepare aldehyde and ketone from alcohol. So oxidation process we have just now we have seen, right? So how we can define this oxidation process? So we can define like this, that the aldehyde can be prepared by oxidation of primary alcohol with normal oxidizing agents such as potassium dichromate or potassium permanganate or chromium oxide or sulfuric acid. Okay, and when we talk about the ketone, so for ketone we can say that ketone can be prepared by the oxidation of secondary alcohol with a similar oxidizing agent. So I hope you have understood this, right? So let me give you one example. Suppose we are taking an example of here CS3 CS3 CH2OH. Okay, so if we are oxidizing this in presence of K2Cr2O7 or H2SO4, K2Cr2O7 or H2SO4, in presence of H2SO4, we will get what? We will get CS3CHO, which is we will get CH3CHO, okay, and plus H2O will come out from the reaction, right? So since handwriting is not good, because it become difficult to write on a mobile, right? Because I am making this video from my mobile. So I hope you have understood this, right? Now next we will see by dehydrogenation of alcohol. Okay, so when we talk about the dehydrogenation of alcohol, at that time we are using what? Copper here, because you can see, right? The next method is preparation of alcohol by the dehydrogenation of alcohol. So by the dehydrogenation of alcohol, you can see we are using here copper and 300 degrees Celsius, right? So how we can define this? Aldehyde and ketone can be prepared by dehydrogenation of alcohol, okay, and it is carried out by passing a vapor of alcohol over a reduced copper at around 300 Kelvin, 300 degrees Celsius or 573 Kelvin. What will happen at that time? Primary alcohol will give aldehyde and secondary alcohol will give ketones. Okay, always remember that when we are doing a dehydrogenation of alcohol, so at that time always remember that the primary alcohol will give, in presence of Cu at 300 degrees Celsius, it will give aldehyde, okay, whereas secondary alcohol in presence of Cu at 300 degrees Celsius, it will give ketone. Okay, now again, when we talk about the mass, molar mass of this, molar mass will change, right? If suppose m is the molar mass of this, then it will become m minus 2, because H2 is coming out from the reaction, right? H2 is coming out from the reaction. Here also, if the molar mass is m, it will change into m minus 2, because H2 is coming out from the reaction, right? Now next thing is 3-degree alcohol. 3-degree alcohol, we cannot dehydrogenate the 3-degree alcohol. Okay, tertiary alcohol, if we will use the same thing, that Cu at 300 degrees Celsius, water will come out from the reaction and it will form alkene. It will not form aldehyde or ketone. Okay, so always remember that 3-degree alcohol on catalytic dehydrogenation, it will not form aldehyde or ketone. Okay, it will form alkene, right? Whose molar mass will be less than 18. As you can see, if molar mass of this is m, it will be m minus 18. Okay, now you can see one example is also I have given here, right? Here using here 3-degree alcohol. What is this? Let me write here. Just like this. Here hydrogen and here OH. Okay, so when we are doing in presence of Cu or in presence of Cu at 300 573 Kelvin, so it will form alkene, which will be like this. Okay, so I hope you have understood this, right? Now the next method is by ozonolysis of alkene. Okay, the next method is ozonolysis of alkenes. So when we talk about the ozonolysis of alkenes, here what we can say, alkenes react with ozone to form ozonoid. Okay, which on subsequent cleavage with zinc dust and water to give aldehyde and ketone. Okay, so as you can see in the first part what we have used here, so as you can see one alkene we have taken. In first of all we have ozonolized this in presence of O3. So what we have got, we have got here in presence of O3 and CH3 2 times S sulfur, we will get here what, aldehyde, right? And as well as ketone, and the byproduct will be this CH3 2 times sulfur S double bond O, right? So when we talk about the oxidation state, so here you can see that the sulfur is in the -2 oxidation state, but it has changed into 0 here, right? So by in this way you can ozonolyze this in presence of O3 and CH3 2 times S, so it will form aldehyde as well as ketone, right, simultaneously. Again you can see one more example here. If we are using this CH3 O2 and the same reagent, so at that time what we have got, this double bond has break, right? And in place of this double bond, two keto group has attached here. Okay, sorry, in one place the ketone group is there, and this is called a keto group, and this is what, aldehyde group has attached here, right? So as you can see, one example I have given you. If CH2 is here, as you can see, CH2 and CH2 is here, when it will break, it will form 2SCHO. Okay, and when CH3CH double bond CH2 will break, it will form CH3CHO and CH2O. Okay, now again after this we will see radio reductive. Okay, reductive. Okay, so these are called reductive elements. As you can see, O3 Zn H2O, O3 DMS and H2O. So here you see, if you are taking double bond CH2, so it will change into HC double bond O. Again if you are taking double bond CHR, at that time it will change into aldehyde. Okay, if we are taking double bond CRR, at a time it will change into ketone, as you can see here, right? Now next we will see hydroboronation, oxidation of alkyne. Okay, so oxidation of alkyne is of two type actually. One is by hydration of alkynes, and another one is hydroboronation oxidation reaction. Okay, or we can say hydroboronation oxidation of alkene. So the first what we will see, the hydroboronation of alkene. So here this is also called, it is also called here, the actually there is happening an anti-Marconic Ox rule we are applying here, right? So let me explain you what is this reaction. So when here in this reaction the alkenes can be converted into aldehyde or ketones. Okay, alkynes can be converted into aldehyde and ketone by hydroboronation oxidation reaction. Here what is happening, borene. Okay, borine, we used to add borine to an alkyne forming vinylic boron, okay, which on oxidation with H2O2, okay, will give aldehyde and ketone. Now the symmetrical or non-terminal alkynes gives a single ketone, while unsymmetrical or non-terminal alkynes gives a mixture of both ketone as well as methyl ketone permanent. Okay, we will see here. So as you can see, one alkyne we have taken, and in presence of SiA2BH or H2O2 or NaOH, it is forming an intermediate like this. After that, when we are in the presence of OH negative, when OH negative will come out from here, it will form here aldehyde, right? It is forming aldehyde here, right? Now again, as you can see, one alkyne is here in presence of SiA2BH or H2O2 or NaOH, it is forming what? Aldehyde, right? So now when we talk about the terminal, so as you can see, when terminal alkenes will give aldehyde, okay, for example, as you can see, these are what? These are terminal alkenes, right? So this type, the terminal alkenes will give aldehyde, okay, but the non-terminal alkenes will give ketones, as you can see here, right? And the terminal alkenes will give what? Aldehyde, but when then there are non-terminal alkenes, it will give ketone, right? So this is example of non-terminal alkene. Now one question is here, as you can see, what will be the product of this reaction? So the answer will be this, right? This and this. Now next is from Grignard reagent. So when we talk about from the preparation of alkenes from Grignard reagent, we will see here is ester. When ester will react with Grignard reagent, it will form either aldehyde or it will form either ketone. Okay, so how and it is happening, you will see. Suppose we have taken here HCOOH, okay, which is a formic ethers, okay, ester, sorry, formic ester. So in formic ester, you will see that and formic ester, and we have taken here Grignard reagent. So in Grignard reagent, you know that this part is the positive part and this part is the negative part, right? This part is a negative part and this part is a positive part, right? So what will happen? Since here this in between this carbon and this oxygen, this will have a positive charge and this will have a negative charge, right? Because oxygen, there is a oxygen will take oxygen more electronegative than carbon. So now what will happen? The positive will attack to negative and the negative will attack to positive. Same thing, right? So what will happen? Here, this R will go and attack to this carbon, okay? So when this R will go and attack to this carbon, it will form a compound which is like this, as you can see, like this, right? Compound will form here. Now what will happen next? This oxygen will shift here, the charge will shift here, this charge will shift here, and this will come out from the reaction and it will form CHO, as you can see. I hope you are understanding this, right? In the first case, this one has attacked here, okay, and this one has come out like this. And in the second case, what happened? This one, if it's coming out from the reaction, this one is coming out from the reaction, and this one is charge is shifting here and it is forming what? R dash CHO, which is an aldehyde, right? Now one more example is for ketone. So when we talk the example of ketone, here what we can see, this RMgX is reacting with this and it will take out this, right? And after that, this R will go and attack to this carbon and it will form ketone here, right? So it is very easy, right? As you can see, the reaction is very easy. So this was about the preparation from Grignard reagent. So one more thing is there, preparation of Grignard reagent with methyl cyanide, or we can say that alkyl cyanide or nitrile. So when we talk when we take here nitriles or alkyl cyanide, as you can see, so here in this part also, this one is positive part and this one is negative part, right? So when we are taking here Grignard reagent, so the what will happen, the positive part of the Grignard reagent will attack to the negative part of the nitrile, and the negative part of the Grignard reagent will attack the positive part of the nitrile, as you can see, it is attacking the carbon, and this one is attacking the nitrogen. So what it will form? It will form like this, and after that, since this double bond will broke from here, okay, this double bond will break in presence of H3O positive. So this double bond will break and it will form here, as you can see, ketone, okay, and MgNH2 will come out from the reaction. Now from this reaction, always remember that from this method we cannot make aldehyde, okay. From this method we will always, we can always make ketone, not aldehyde, okay. Alkyl cyanide, how, what is happening here? This is also called Stefan reduction type reaction, okay. We will discuss about this in detail also. So from this reaction we cannot make aldehyde, right? Now next one is very simple, from calcium or barium salt of carboxylic acid. So here in this question, in this part, we will use here calcium or barium salt, and nothing we have to do, nothing, just we will take calcium or barium salt, we will heat that, it will change into either ketone or it will change into aldehyde, okay. So first example, as you can see, when we are taking here calcium salt, as you can see, we have used here calcium salt. When we have heated this, so this part has came out from here, right? This part, let me draw like this. This part will come out from the, this part will come out, right, and we will get this ketone. Now next, again, if you are taking this, so what will happen? It will form this and this, right? There is also a ketone here. Now again, if you are taking this example, it will form this. If you are taking this, it will form this. So it is very easy, right? Everything is same, as you can see. So from this method, from calcium or barium salt of carboxylic acid, we can easily make, nothing we have to do, nothing, no reagent is required. Just what we have to do, we have to heat that reaction. So one more example, as you can see here, we are taking COOH, and here we have used CS3COOCA, right? So at that time, what will happen? It will react like this. It will take this part, right? What we have got? CS3COOH we have got, right? So this part will come out from the reaction, CaCO3, okay. Sorry, this one, CaCO3, 1 2 3, right? So CaCO3 will come out from the reaction, right? Add this aldehyde and CaC, calcium carbonate, will come out from the reaction. So now next is reaction from acyl chloride. So it is also very easy. In presence of Grignard reagent, we are doing this, right? We have taken one acyl chloride, it will be taken in excess, okay. So what will happen? This R, since it is carrying a negative charge, it will attack to this carbon, and when it will attack to this carbon, the Cl will come out from the reaction. So we will get this ketone, right? Now after that, again, when we are taking this, here again, this MgBr will take this Cl, and then CS3 will come and attach to this carbon, so we will get CS3CH. This one is also same, Cl will taken by this MgBr, and this CS3 will come and attach to this carbon, as you can see here. So here some of the example is also given, as you can see. So what will happen? In place of NH, in presence of H3O positive, we will get what? O, ketone will come, right? Again, in place of this what we will get? We will get ketone. Again, in place of this, what we will get? We will get ketone, and OH will come out from here, right? So I hope you have understood this. Now next is by hydrolysis of gem dihalide, right? From gem dihalide. So gem dihalide contains two halogen atom, okay. When you will see the gem dihalide actually it used to contain two halogen atom on the same carbon atom, and on hydrolysis it will give what? Carbonyl group. So as you can see, on the same carbon, two halogen atom has been attached, right? Two halogen atom has been attached on the same carbon, as you can see here. So in presence of aqueous KOH, okay, so what it will give? It will give carbonyl group, which is this. So when you will when you will hydrolyze this, and when we will hydrolyze this in presence of KOH, when we will add the KOH here, so what will happen in place of this two alkyl group, halogen is there, no? So in place of this OH will come, as you can see, right? In place of this OH has come. Now again, when we further we will hydrolyze this, we will get this carbonyl group, as you can see. One more example is there. So if it is like this in presence of NaOH, so what will happen in place of this Cl and this Cl, what will come? Keto group will come, right? Again in place of this keto group will come, right? It is very easy, right? I hope you are understanding this. Now next is weaker process. So by weaker process is what? Here alkenes can be converted into aldehyde or ketones by treating with an acidified aqueous solution of palladium chloride, PTCl2, containing a catalytic amount of cupric chloride, which is CuCl2, in presence of air or oxygen. Okay, this method is called what? Weaker process. So here, what is the reagent? What is the main reagent we are using in this reaction? So the reagent is, as you can see, acidified PDCl2. Okay, and after that, as you can see, acidified PDCl2, CuCl2 or H2O. These are the reagent which we are using here. So what will happen here? So it will form aldehyde as well as ketone, right? So when you are using this, suppose this is a one compound here. So in this compound, where we are using, what we are doing in this compound, we are adding PDCl2, CuCl2 or H2O, and in the acidic medium, right, H positive is there. So in acidic medium, what it will give? It will give aldehyde as well as it will give ketone, as you can see here, right? So what is happening basically, in place of this double bond, CHO is coming, right? And in place of this double bond, O is coming, right? Now again, one more example is there, as you can see. If you are taking this example, so in this double bond, in place of this double bond, what will happen here? In place of CuCl2, PDCl2 or H2O, it will give this. One more example I will give you. Suppose we have a propene. Okay, suppose we have propene, which is CH3 CH double bond CH2. Okay, so now in presence of this PDCl2 or CaCl2, PDCl2 or H2O, it will give acetone. Okay, which is CH3CO, CH3. Okay, and PD and plus 2HCl will come out from the reaction. Okay, so I hope you have understood this, right? Now we will see Stefan's method, or we can say Stefan's reaction. This is a very important reaction for your exam point of view also. Alkyl cyanide. We are using here alkyl cyanide. So in presence of SnCl2 or HCl, it will give what? It will give first of all intermediate, this one, and which is further hydrolyzed to give aldehyde, right? And NH3 will come out from the reaction. Why? NH3 is what? Which is called what? Parrots of chemistry, right? It will come out from the reaction. It will run away from the reaction. So what is the basic idea about this, or what we can say? So from this method only we can made aldehyde. Okay, right? And the intermediates which will form here, it will be imine, amine. This is what? Amine, right? For what were the two basic features of this reaction is that from this reaction we can only made aldehyde, and number two, this the intermediate is imine. Okay, now next is, I hope you have understood this reaction, right? So one example is there, as you can see. Now one more example which is very important here. If we are taking, suppose we are taking what here? SnCl2, right? SnCl2. But if we are taking in place of SnCl2 and HCl, if we are taking SnHCl, so the reaction will be completely different. Okay, so at that time when you are using, suppose this is a nitrile alkyl cyanide, and when we are using, as you can see, when you are using SnHCl, at that time the reaction is different, right? It is forming what? RCH2NH2. But when you are using SnCl2 and HCl in presence of H2O, then only then we are getting all aldehyde. right? I hope you have understood this, right? If we are taking SnCl2, then only we will get aldehyde, otherwise we will not get aldehyde, we will get this, right? So this was the third important criteria about this Stefan's method, right? So this is some of the example. As you can see, if we are using SnCl2 HCl, we are getting aldehyde. Again, when we are taking in this reaction SnCl2 and we are taking HCl, we are getting aldehyde. But when we are taking SnHCl, at that time we are getting amine, right? As you can see here. So it is very easy. I hope you are understanding this, right? Now next is Rosenmund reactions. Rosenmund reduction, or it is also called Rosenmund's reactions. Rosenmund's reaction. So here what is happening, let me explain you. So in this reaction, here we are using acid chlorides, okay? Here basically acid chlorides are converted into aldehyde by catalytic hydrogenation in presence of palladium catalyst, supported over a barium sulfate, okay? Now the catalytic mixture, which will be poisonous, okay, by adding a small amount of sulfur or quinoline, this type of reaction is called what? uh, Rosenmund reduction, okay. What we are taking, acid chloride is converted into aldehyde by catalytic hydrogenation in presence of palladium catalyst, supported over a barium sulfate. The catalytic mixture is poisoned by adding by the addition of small amount of sulfur or quinone, right? So as you can see, what we have used here, acetyl chloride, right? So in presence of H in presence of PD, BaSO4 and H2, it will give what? Aldehyde, as you can see here, right? What is happening here? Always remember that. In place of, if you're taking the example of this, you will see in place of Cl, hydrogen is coming, right? In place of Cl, hydrogen is coming, right? In this reaction, everything is same as it is, but in place of Cl, hydrogen is came. You can take the example of this also. In place of this chloride, hydrogen is came, right? And everything is same as it is, because you can write. Now again, in this case, you will see in place of Cl, hydrogen has came, right? So I hope you have understood this reaction, which is called Rosenmund reduction, okay. Now next is Oxo reaction. Oxo reaction, here catalyst is CaCO2 CO8, okay, which is also called octacarbonyl dicobalt. As you can see, I have written the name here also, octacarbonyl dicobalt. Here we are using catalyst as a octacarbonyl dicobalt, carbonyl dicobalt we are using here, right? So in this reaction, as you can see, we are using here this in presence of carbon dioxide and H2, carbon monoxide and H2, and in presence of octacarbonyl dicobalt, as you can see, we are getting what? Aldehyde, right? So here what is happening, you see, again, if you are taking the example of this, here double bond has break, and in place of this CHOS came, right? So I hope we are understanding this. It is very easy, right? So what is happening, this double bond will break, and in place of double bond CHO will come, as you can see here also the same thing, CHOS came, right? Now next is preparation for ketone only. From this reaction we can prepare only ketone. So first is from alkyl cyanide. So when we are taking here alkyl cyanide in presence of Grignard reagent, okay, so same thing will happen, the plus of this will attack to this, the minus of this will attack to this, right? As you can see, through this carbon this R has attached, and through this N this MgX has attached. Now again further hydrolysis we will get ketone here, right? Same thing here also, CS3 C triple bond nitrogen. So here you can see in place of this CS3 will go to this carbon, and this nitrogen will attack to this MgBr, right? So as you can see here, what is the product here? So I hope you have understood this, right? Now next is Biketonic of acetoacetic ester and their alkyl derivatives. So this is also very easy. Now by looking we are getting it is look like that it is very confusing, but it is also very simple. As you can see, what we are using here, CS3CO CS2COOR. Okay, so in presence of NaOH and H2O, what we are getting, we are getting in, it is breaking from here, it is breaking from here, right? So in place of this H2, CS3S came, as you can see, and this will come out here and here. Okay, one more example is here, CS3CO CS2 COO COCS2 C2H5. So from where it will break, it will break from here. Okay, so when it will break from here, we will get CS3 COO CO CS3. Okay, after that, by taking this Na2 sodium from here and carbon and oxygen from here, it will form Na2CO3, and after that this C2H5, and by taking the OH from here, it will come here, right, as it is. So it is also easy, right? No. Next is by dialkyl cadmium with acid chloride. So here we will use dialkyl cadmium. Okay, when we are taking here CdR2 R2 or R dash anything, so at that time this CD is taking this Cl2, right, and it is, this will go and attach here. So what we will get, we will get 2RCOR and CdCl2 will come out from the reaction. In the same case here also, in place of this Cl, this CD and this R will come. Okay, and this Cl will come out from the reaction. This CD will take this Cl, right, and this will go and attack here. So as you can see here, the reactions are very simple. As you can see, if you will see it, look at carefully, you will automatically, it will fit in your mind. So this was all about the preparation of aldehydes and ketones, right? Now in the, from the next class we will discuss about the physical and the chemical properties of aldehyde and ketones. Okay, so I hope today's class you have understood, right? So in case of any doubt, you can ask me, you can write it in a comment section. Okay, so till that, thank you.